This is the it factor for what we've been looking for. When I was at the utilities, you can see here in 1998, we won the Innovation Project of the Year. And when I walked away and they gave all the things that we were achieving, I couldn't help from thinking that it was nice to hear what they were saying, but we really did not achieve all that. There was still a lot of gaps. Even though we had put in a lot of systems and a lot of technology, there was still a lot of gaps. And that gap was, it really wasn't about infrastructure. You know, in the late 90s, we were still talking about building smart meters and smart infrastructure, whatever that might be. And we were so focused on the technology and the hardware that we really, in many ways, didn't start with the end in mind. And that is, what are you going to do with that intelligence? How do you get to that intelligence? How do you begin to evaluate that intelligence? So, you know, flash forward to in actually 2014, when I was at the utility industry, we began to look at creating a microgrid. A microgrid of about 700 acres. And we had literally put in solar, battery storage, smart grid technologies. We had spent, I was telling Vish, which I had a great opportunity to visit with Vish earlier, about the fact of how much we'd invested in this microgrid. And I believe there's a lot of microgrids like this today that are being created, being called smart microgrids, called smart cities, whatever you want to call them. And I don't believe they are. And the reason I say that is because really, when it comes to being smart, it means we have the ability to make it intelligent, intuitive, the ability for things to talk to one another, to make it to where it's experiential. And we were battling with this as well. Why? Because we didn't have the ability to bring it into a common architecture, common platform. And that's why we started this whole journey back in about 2012, 2014 to say there's got to be a better way of managing this. And one of the things you'll hear me say is we really need to be thinking in terms of generation to toaster. In this industry that we're a part of, so much of it is about generation or transmission or distribution or what's beyond your meter. How many of you have smart technologies in your home? You raise your hand. How many of you have just one app on your phone that manages all those applications? If anybody raises their hand, I'd love to visit with you afterwards because that's a rarity. You know this, that we're installing these technologies in our home and we're installing them in buildings and we're just building more and more silos in the process. And what our platform is all about is how do we create a common platform from generation to toaster. Some of the things I'd like just to share with you are on this topic list and I'm going to continue to kind of keep moving here. I've got that 40-minute in my head, so I'm a fast talker, so hopefully I'll get through all the content I have for you today. But I want to talk a little bit about our why, our how, and our what. I want to talk a little bit about our platform, and one of the key words, I would say the operative word, if you will, is interoperability. Interoperability of not just data, but devices, of technologies. And then we'd like to talk to you a little bit about the graph technology or architecture that we set on, which is Neo4j. And Mike Welch, thank you for inviting me here today, who's our rep in Texas. I would talk with you about a couple use cases. We've got a gentleman here today, Les Penning, who's the CEO of Oregon Trails. We're doing a really exciting project with in terms of fire protection, or fire detection, I should say. Fire protection would be a good thing too, right, Les? And then also talk a little bit about transactive energy, blockchain technology, if you will. So let me jump right in. I want to first just share with you kind of this idea of what we see happening in the market. And you probably know some of these things, but think about it. 90% of the data we've ever generated has been generated in the last 2 to 5 years, and 80% of that data is unstructured data. It says something. In the utility sector, only less than 4% of the data that we're collecting is being used, and yet we're spending tens of millions, if not hundreds of millions of dollars in actually putting in assets and in creating that intelligence. If you think about how much data is being generated from a smart city, 250 terabytes or petabytes in one day, 150 gigabytes coming from a building, 220 million devices being installed by every hour by 2025. Think about how much data that represents. And how many of you would agree, boy, wouldn't it have been nice to bring all that together and see all that intelligence in one space and literally be able to do things, the exciting things that Emma was talking about today. Of course, we always know you follow the money as well. So look at the kind of dollars that are tied to this type of industry, what people are valuing. And really when it's all said and done, and you would agree, it's not just a matter of putting those values on data, but I would argue it's more importantly, it's putting the value on the insights, the actionable data that's behind that. Because that's where really we start seeing the return on investment. So what really our platform at NX was all about is how do we, one, create a virtual grid from generation to toaster. a virtual grid just that follows the same pattern as a physical grid? How do we connect all that data? How do we connect the people? Because I think what's important is that so often that we talk about assets and infrastructure as though they stand alone from the people who operate those, and I need to work with those in a behavioral way and an intuitive way. So having the ability to connect behaviors to the assets, and then also connecting real solutions. Real solutions like that of public safety power shutoff in fires in Oregon, and that's just to name one, and many others that we can create through this technology. And then of course transactive energy, and you're going to hear me say in a few moments that transactive energy to us is not a linear thing. It doesn't mean that the generator is the one making the money. What if you were making money? What if you were empowered to be a prosumer instead of just a consumer? What if you could turn your assets just like you do your car? I don't know if anybody does Uber in here, but what if we could Uberize your assets? What if we could take your HVAC unit or take HVAC units of facilities or assets of facilities, instead of that being a consumption, that it also could produce into the marketplace? And I'll give you examples in a few moments why we believe our platform would give us the ability to do that. If you were to type in electricity transmission networks, you would literally see that this is what would come up. And how many of you would agree it looks like a graph? Because the utility network really is a graph. And so then in large part, as we started looking at doing this, that was what we were really striving to do, is to create that kind of architecture. Because today, what's prohibiting the grid from being as efficient as we can make it is it's linear. And I think all of us would agree that many things become far more efficient when they can be bidirectional, when many people can see the data, many people could be a part of that transaction, that it be somewhat of a hybrid platform. And what you're looking at here is the traditional approach, but what NX does, and what we do with the graph, is we turn that into a bidirectional by our energy platform, which again sets on the graph. So what that looks like, if you were to take this same image, is it literally is setting the graph on top of that entire grid. And so now we have the ability to see that. So if you went to an article, and I would encourage you to download this, it's online. It's an article called Navigant Energy Cloud 4.0. A lot of what you'll see today, there's a lot of references in that. You can download it to free PDF. It's a white paper. It talks a great deal, as you can see on the right, about this energy cloud. And one of the things that I think is so important, as you can see in that, is this two-way power flows, where we have the ability to begin to look at power differently than just transporting it from 100 miles away to your home. What if you could begin to actually not only turn your home into a power producer as well as a potentially power consumer? So what's that look like if you think about the graph? Because what you're looking at here, and if you look across the top, we all know that all this data really is what we would call the hidden layer. It's data that's hidden from us, even though it's in our databases, even though we have master data management systems, and even though we have data lakes, and we're bringing all this data, it's still hidden from many of us. I mean, many times we can't walk into our command centers or wherever it may be and say, I want to see this, this, and this, and I want to see it instantaneously. And keep in mind that much of what happens in the utility industry is real time. You don't have the ability to tell a consumer, we'll get your lights on in a week from now once we figure the data out. You know, they want to know it right now, and of course the whole purpose of the data is to achieve that. I love the statement, we don't know what we don't know, we can't act on what we don't know, we won't know what we don't search, we won't search what we don't question, and hence we just don't know. And I don't know about you, but I want to know. And when you're in the industry, you want to know. And knowing is so valuable. So what if you could know some things you never knew before? And what if you could take and begin to take this data and actually harmonize it across the whole grid? That I can harmonize it not only from the standpoint of generation, but I can harmonize it across the transmission and the distribution, because the energy as we know it is not a vacuum. It never has been in a vacuum. It has always been about getting an electron to your house, right? I mean, at the end of the day, it's all you care about. Does an electron work? So you turn the light switch on, it works. And so one of the things we have the ability to do with the graph is, if I can bring that all together, I can literally do things that are now in what I would call the hidden layer, not the input layer, but the hidden layer, where I can do forecasting of load like I've never done before. Think about this for a moment. On average, in the utility industry, we spend 30% more on building infrastructure because we want to make sure we build enough. We spend 30% more on operating costs because we spend so much more on the infrastructure. And we really never do a good job of of forecasting the load, the source, meaning the generation, against the load. I did years of doing this, and I can tell you the science is basically this. I think that'll get it. Now, for some in the industry, and I don't mean, and again, I hope that doesn't offend you, but I really believe that in some ways we're just kind of working off historical data that isn't based on intelligence. We know it today. But what if we could do that? What if we could increase our reliability because of what we're talking about? How many of you are living in a state where they're talking about rolling blackouts? If you live in California, you live in Texas, you live in different places, they're talking about rolling blackouts. Who would have thought? Here we are in the 2022, and we're talking about rolling blackouts in this day and age. We shouldn't be talking about that. And also just contingency planning. But if we can do that, if we can do those kinds of things, then our output layer begins to really uncover risk and what those risks are. And we can then begin to do the things, the very meaningful things that are predictive actions and prescriptive actions. That has been, at least my dream for many years, is can we do that? And I say we can. And I would say that the graph technology is that that has enabled that. Inside our Insight Center, this just kind of gives you a screenshot of how we're basically creating a scenario builder where we can run different scenarios against things like line loss and load factor and vegetation management, the things that we talk about in the utility industry. But let me now talk about really kind of the energy platform, if you will. And this, as you see on the screen, was actually from an article from EnXchange talking about what it means to change it, to make it, and the secret of being a champion. And the one thing I covered or circled in red is because I think it speaks volumes to what industries must do, and that is that we must build platforms that are interoperable. Interoperable meaning platforms that have the ability for data to be shared. Platforms that mean that as we build more and more infrastructure, think about how much money is going to be spent in the next probably 2 or 3 years from this existing infrastructure bill. How many of you truly believe that infrastructure bill is going to create more connections and more data integration than where we are today? I doubt it does. So every time we build assets, if we're not building on an architecture like this, we're building more assets of siloed data, siloed systems, rather than a system of systems, which is really what the NX platform is about, is a system of systems. This gives you kind of a one snapshot picture of what we believe an energy platform must consist of. First of all, as you can see from this, it has to have the ability to connect any and all physical assets and devices in one platform, which is unheard of today. It must have the ability to not just connect physical assets, but we've got to be able to connect people and people's behaviors and understand what's going on with that as well. But as you can see down at the bottom, we have to have the ability to have agnostic devices and hardware. Now, you know this as well as I do, that a lot of the companies that are in the manufacturing today do not want to necessarily be interoperable because proprietary means that you create a captive audience. But I think one of the things that graph technologies are doing is it's forcing a more open architecture, a more agnostic architecture. So our platform is all about the ability to not only connect at the generation level, so take a microgrid as a good example, solar, battery storage, backup generation, EV charging, which I would call front of the meter. But what about beyond the meter, inside the building, HVAC, water heating, boiler systems, lighting, whatever it may be? What if we can connect that data? How much more efficient could we be? So the argument that people will make that, well, solar doesn't work because the sun doesn't shine all the time. We get that, right? We get that. That's just part of the nature of that application. Or battery doesn't work because it bleeds off in 4 to 6 hours. Or, there are all kinds of people who are enemies of innovation. That's the reason I encourage you to read that book, because I call those folks enemies of innovation. Because the reality is we're not talking about those systems working independently. We're talking about them working harmoniously. We're talking about those systems working in an aggregate way. I had one of the gentleman in the utility industry who told me one day before I left the utility work, he said, I don't believe that we can make this work. But he said, if you do, it'll transform our environment. That's why the session's the energy sector, because I truly believe we're there, that we have the ability to do that with technologies like the graph. So the graph model you see as a key component. You can see what we call a JEB controller. If you've never heard of the JEB controller, you can go to DOE, Department of Energy, you can go to NREL, you can go to a lot of different places. JEB means Grid Interactive Efficient Building. That means this building should talk to the grid. I mean, wouldn't that be cool with the graph? It just what's happening temperature-wise outside, what's happening with occupancy level inside. How many of you, before you left your room today, said, I'm going to make sure I turn that down to 68 degrees because I don't want ERCOT to be without power? Did anybody do that? It wasn't on your mind, and it shouldn't be on your mind. But what if we had the ability, because we knew occupancy, we knew you walked out of the room, so therefore there's nobody occupant in that, and we regulated that intuitively because we don't need to use that energy. But I would venture to say every one of us, and probably myself included, probably left our air conditioner on about 68 degrees because it's hot out. When you walk in, you want to know it's there, right? But there's all kinds of technologies that allow us to make buildings intuitively and manage that modulation of energy, if you will. And then, of course, the last one is it's imperative that we have the ability to bring this into one visualization tool. So if you broke that down, and this is kind of just to drive home my point, it's that ability to take devices, hardware from any of these disruptive technologies. So when you look at the bottom there, each of those 5 represent what I would call disruptive technologies in our marketplace. Neural grids, smart grids, distributed energy, IoT, smart buildings, EV, microgrids. They all have the ability or have the effect of potentially disrupting the market unless there's a platform that captures and harnesses that value. And so you see here that the first layer of our platform is to capture that in an agnostic, as I said earlier. It has the ability to do the data mapping, the graph. It has the ability to do control schemes, as I shared on the JEB controller. And it has the ability to create the data visualization. So really what I wanted to show you the slide for is because when it's all said and done, very few people really care about what the platform does. But most people care about their energy bill, about their assets, about the environment, and about resiliency. Would you agree? Those are the things they care about. So what we have to do is create that platform that creates that experience that sets on the graph that ultimately allows these things to be accomplished. And those are the things that really are our true north when it's all said and done. We love the technology and the platform, but at the end of the day, we want to make it to where the consumer, the user, just really has the experience. Again, to drive home the platform in regards to another component, and that is this idea from generation to toaster. So this just gives you an example of what we've been doing in modeling the graph. This isn't the total model, but you've got to think about it from the standpoint there's got to be a model at the generation level, there's got to be a model at the transmission level, a model at the distribution level, and a model beyond the meter. And so what you see here is, again, this effect of generation to toaster, but equally, when you go along that value chain, because this value chain, as you see it, is a broken value chain. In other words, the whole idea of blockchain technology, the whole idea of interconnection means we got to break down that siloed nodes, bring that into one system to where now, along that value chain, users can log into our Insight Center and see what is relevant to them. A generator can see generation, a transmission can see transmission, a distribution can see distribution. Now we begin to see that harmonization. Now we begin to see where we can take, I don't know if you're familiar with load factor. Load factor basically means this. Whatever you set at a peak, it has to do with how much energy you use on a normal basis, normalized basis against that peak. Most of the time, energy or load factor is about 50%. So that means a lot of times we're setting a demand which we never use a lot of times. But if we can do this, we can begin to flatten the curve, if you will, and really begin to affect the technology such as solar, such as battery, and other things such as that. So that gives you a little bit of idea of how we see that transpiring. Wanted to just give you a quick screenshot, kind of the home screen of our Insight Center. And as you can see over here to the left, it's basically different applications. So we basically empower users to have their own dashboard. Think about this. What if you could log in, let's say at your building, and in one place you could see the analytics from every single asset, or any analytic that you've done across your system? I don't think very few can do that today. Have the ability to go to assets and see a place where you see all of your assets and all the intelligence tied to that assets. To actually see kind of across the enterprise and see what the pulse is because all the data is coming into one place. To have the ability to go to an analytic gallery and choose any analytics associated with whatever part of your enterprise you want to see in one place. And then of course we have the view of the enterprise graph where we want to give, and when I use the word enterprise, whatever that ecosystem looks like, whatever that network looks like. This morning I really appreciated hearing more about this whole, sharding of graphs, the fabric of graphs. Our technology is built on that. a federation of graphs and a fabric of graphs, meaning that we have this ability to work with utilities from all different aspects of the vertical sector. So you're kind of seeing this, this technology or this architecture here, where we have been building out a global utility graph and structuring data that comes all the way from customer information system to energy or the energy asset management system or enterprise asset management, advanced meter infrastructure, the system control data acquisition, outage management information, geographic information, and structuring that to where that can come into utilities. There's over 150 to 180 IOUs across the country, nearly 2,000 municipals, nearly 850 cooperatives, and we're creating the structure to where whomever it may be from a utility experience, a lot of that data can come into our system and be pre-structured, pre-modeled in terms of a graph. But what is equally important as we start thinking about this bi-directional approach is what if we can provide to those utilities the ability to also move the data in a structured way from these disruptive technologies? How do we begin to empower them to say that, hey, when a solar array comes on your system, we have a graph model that already will ingest that data from that solar array. Or if an EV charger comes on your system, we already have a graph model that does that in the graph. So ultimately, they have the ability to actually create a virtualized experience of their graph. And all of that then pushes into the Insight Center. And again, you keep seeing this word down at the bottom, the idea of being no longer just a consumer, but now I can literally become a prosumer. I can Uberize my assets. I can begin to participate rather than just be one that's being a consumption side. The other thing we're really excited about this technology is being able to begin to look at patterns beyond just local patterns or a local utility, starting to look across this on a global capability. Think about it, a grid's a grid in many ways. Don't get me wrong, we all build grids just a little bit different, but a utility grid, when you look at transmission and you look at substations and distribution, and I know I'd probably offend some engineers by saying that, but ultimately it takes certain componentry and certain infrastructure to move an electron. And if we can begin to look at that grid in a virtual way, begin to think of what we can do in machine learning, where we can begin to compare weather patterns, begin to compare different devices. GE said the other day that sensors are going to grow like daisies. Well, you know, if we're going to continue to see more and more sensors that have the ability to sense different aspects of the grid, how amazing would it be if we could bring that into a global utility graph and begin to compare that across a larger data set rather than just one local utility. I'll give you just another snapshot of how we harmonize data or how we're harmonizing data and bringing that data into one knowledge graph. So you can see up here the CIS, FIS data I was talking about a moment ago, and of course all the other systems that are in the utility sector. Our goal is to give them the ability to bring all that data into the Insight Center, into our graph architecture, so we can harmonize that data and literally then move to that area that I mentioned with the idea of the end in mind, to project the things like predictive analytics, prescriptive analytics, to do things that are actionable data versus just being reactive in many ways as we are today. So those are the real business solutions. If you're to look at how that plays out, let me just give you a couple of examples that excites me, because I used to spend 30 plus years in the utility industry, and I was at the distribution level. So above me, you might say, was a generation transmission company that actually generated power, built transmission to the substations I owned, and then I didn't own them, our members owned them. I should better say that. I've been away too long, Les. Our members owned, and we would move that power to the members' homes. And so we had to share data with the G&T. So what you're looking at here is a model we had shared with another generation transmission company. So that generation transmission company is exchanging data all the time with these distribution co-ops. And how amazing would it be that they have the ability to basically, through our system, one system, to begin to create that ability to share data. Data that's relative, data that allows the kind of forecasting and things that I shared with you earlier. But take it a step further. Let's just say that one of these distribution cooperatives here says that's all good and fine, but I want to be able to share that data further down with my members, with my particular customers. So it may be that it's a hospital, a school, whomever else it may be. So this gets down to that granular level. that the graph allows us to work with, where we can truly begin to go from front of the meter to behind the meter. I would venture to say that probably very few in here, or if anybody in here, can say that your utility has a good understanding of what's beyond the meter in terms of, especially from a physical building. But those are the kinds of things we need to be looking at. Those are the kind of things we can do through this graph architecture. Let me give you a couple of use cases of how we're using the graph and what we're doing with a couple I call key accounts, and Les Penning, who's with Oregon Trails Electric Cooperative, we're working with him. And one of the things that we're working with Les on is how to manage a grid. And this is a one-line diagram of a grid. If it looks busy, it's because a grid is a very busy network. And what you're looking at here is a substation, and where you see F1, F2, F3, F4, those are main feeders. So what I'm showing you is one main feeder that's being drawn out and kind of showing you all this downline intelligence and data. And what you'll see in the red diamond is weather sensors, and you also see what we see here as guy wire sensors. So what we're doing with Oregon Trails is we are looking at downline sensors, weather and guy wire, which tells us the strain of the grid, and we're correlating that and giving feedback as to, based on that data, are we anticipating that we need to shut down a substation, so that in this case, the substation doesn't face a situation where it starts a fire, that we don't have a down line, or the conditions aren't as such that it creates that. Many of you are familiar with what's happening with PG&E in California, or what has happened, and it has, across 17 states, created some significant problems. So think about it. The ability to look at all these sensors downline, which could be more than just the weather sensors and the guy wire sensors, let's say it's hundreds of sensors, and to be able to bring those in and to be able to analyze that and to say, I don't have to shut down a substation because that substation represents a large area, but because I know it at the feeder level, I'm just going to shut down the feeder. As a customer, as you and I in here, I'd like to think that the utility's not just shutting it down at a substation, which is affecting hundreds, if not thousands of customers, but maybe shutting down a feeder or maybe shutting down a phase that's only affecting a few. That's the kind of intelligence, and I would venture to say in the future as customers, it's the kind of intelligence we're going to expect from our utility, right? We're going to expect from our utility not to be without power for hours or perhaps days because of these types of situations. And it's not just fires, it could be other types of weather events as well. So that's one use case that I would give you that we're doing with the graph. And I could go on and on about that in other ways. But another one is we're working with a quality care emergency room and looking at demand response. How many of you are familiar with what happened in Texas on February 14th of 2021? Anyone? If you lived through that, you remember it very well. And I think this will drive home a point for you, is that on that day, we had to have rolling blackouts of substations, and some of you may be without power. And if you look at the ERCOT system, this kind of gives you an idea of the overall ERCOT system. There's 5,000 substations within that ERCOT system. And on that particular time frame, those few days, they had to shed as much as 16 gigawatts of power because they lost 35 gigawatts of generation. Here's what I want you to hear is that 35 gigawatts, they also projected in the state of Texas that there was about 35 gigawatts of heating that came online at that same time. So we lost 35 gigawatts of power. We have 35 gigawatts of power coming on because people are heating their homes. They had to drop 16 gigawatts of power during that time frame. But how awesome would it have been to have been able to shed some of that load and never shut down a substation, never lost a life, never had people have to go to the hospital, never had all the things that economically that happened, because we would have the ability to literally manage the load. That's what our platform does. So it gives that ability to look at some very interesting information and say, you know what, on this whole demand response for years, we have worked on this side over here, where it's, I won't trip myself, non-dispatchable load. In other words, if I can see the load, but it's non-dispatchable. I'm not able to move it into the market. Why? Because there's not been this graph technology. If you look at the left side, what we're talking about with the platform that we're talking about here is now that's dispatchable load. Now that's load that can actually come prosumer. We can start to use that in ways to affect the broader grid. As you can see on the far right, we've done things like efficiency and load shedding and load shifting for years, but the one thing that we have not done well is what you see in modulation. What modulation would mean, if you looked at the quality care emergency room, it would mean if we were able to see the HVAC, the water heating, the CT scanner, the X-ray machines, and what you're seeing here, if you can, it's hard to see it, but this spike, that's a spike that happens when a CT scanner comes on. And so that sets a peak demand. The thing that our platform allows from a demand response is that we wouldn't be able to turn down the CT scanner, but what if when that CT scanner is, we're modulating the remaining load, so we're levelizing and balancing the load. That means things like solar and battery and things of that nature become more efficient and become more optimal in the market. And what that looks like basically is all the way from the mechanical room to the generator. Not only are we able to do that through the graph, but what you're seeing here is what we call that JEB controller. And again, it's that ability to potentially put an algorithm at that JEB controller so that happens intuitively. That there's no one that really has to do anything with it. It just happens in an intuitive way because of things we can do within the graph. The last area that I want to just take a few moments, because I have about 5 minutes left here. I asked her if this clock was going to buzz me or shock me or something, so I don't want to be in front of it if I hit 140. But I talk just a moment about interconnections and blockchain, because again, that's something that really fascinates me when we think about transactive energy, because a lot of the use cases that we've shared with you, kind of the true north for NX, especially coming from the energy sector and kind of what's happening holistically, I believe this is kind of the holy grail in our area, is that ability to create transactive energy, to use kind of this blockchain capabilities that's really embedded within this kind of graph architecture. This kind of gives you just the history of what's been happening in this space when you think about blockchain. And we began really kind of looking at that in 2018, 2019, really I just say looking at it. But if you look at 2019, you can see that already we're starting to talk about kind of how that graph looks. And for us, it really is about how do we begin to build our architecture to capture this opportunity, because our platform was never intended to be an asset platform or really a service energy platform, but we really see ourselves as being a network orchestration platform, being able to orchestrate assets, people, and relational data. I loved what Emil said today in terms of that whole contextual relational data and how important that is. I would argue that many of the solar and battery and microgrids that are being installed today are nowhere near optimal levels. Why? Because we don't have a graph technology that's creating that relationship, creating that modulation, creating that understanding from asset to asset, how those assets can work in an optimal way, and that's why you see that up there. So what that looks like for us is basically that ability to create transactive energy along the entire value chain and to go from the consumer to the utility level to the market-based, even to the regional transmission organization. A few more slides, because again, I want to make sure I respect your time and respect the time they've given me, but I want to make sure I hit on a few of these others. So again, back to that Navigant document I sent to you earlier. This points out again just how important it is to consider the value of different types of platforms. We really believe that it takes an ecosystem platform to address this energy market. I shared that with you earlier. It's not just about generation, it's not just about transmission, not just about distribution, it's not just about what's beyond the meter. It means that all that has to be able to work in harmony. It has to be an ecosystem. And as you can see from the red box to the right, that means that you're a network orchestrator. That means you have the ability to bring in assets in an agnostic way. You have the ability to unlock new energy value propositions. We have the ability to create this convergent architecture. So I think one of the things that I just would share with you kind of in a closing way here, I think what's going to be fascinating in this process that we find ourselves in is that when you look at the current, what I would say, ecosystem of grid, it really has been driven top down. You have your RTOs, the regional transmission organizations like ERCOT, you have the generation transmission, the utility, the substations, and then you have us as customers sitting down here at the bottom of this. And really what you've ended up with is overbuilt infrastructure. You end up, because at the top, you don't know up here what the loads are, so therefore you overbuild. And because you overbuild, you end up with less efficiency. And you have more operational deficiencies. And these interconnections are basically paper transactions instead of transactions that can happen along the path. We believe that the path of the future And what's happening in the energy market that's revolutionizing the market is that it needs to start with the load. You, me, those who actually create the need for power. That's the way it should have always been, right? It always should have been, what do I really need as far as power is concerned, and how do we better align the production of that power to my needs? And so here we see that going from a bottom up, where we see more grid optimization. We see decrease in line loss. In other words, an electron being generated to your home, tell me something, just by very nature, if I'm moving an electron 200 miles away to your home, do you think that's more efficient, or do you think it's more efficient if you were using an electron that was right on premises? It would probably tell you that it's probably going to be more efficient and cheaper. Now, there are a lot of obstacles and things we got to overcome, but you'll notice also it's not just about interconnections anymore. It's about smart contracts. It's about building that into the system so that we can truly move to a transactive energy component. And so this diagram shows you that. And what that will require is an overlay of the graph, and to be able to graph that entire architecture, that entire network. I'm going to end with this because I got 1 minute left, and that is that I really, as I said earlier, I do think that one of the things that's probably the most transformational in our industry, and it's part of what I recognize here today when I heard Emil and the staff talking, is having individuals understand there's a different way of thinking about energy. And it's not thinking about battery or thinking about solar or thinking about even where you come down on climate change. I was sharing this with Vish earlier. It's all about how do we be better stewards of technologies and innovations that are at our disposal so we can create optimal experiences for people and create the least amount of cost for people in their areas. I said it earlier and I'll say it again. That is, that is not, is that not it? Thank you so much.